Okay, so we've got we've already seen how to represent the budget of a consumer, which constrains what the consumer is able to purchase or able to acquire, and we've represented the consumer's preferences, which tells us what they want. So we have, as part of our definition of demand, the ability and willingness to buy some quantity of goods at a given price. We're ready to do that now. So we need to combine the indifference curves, or the indifference map, showing the consumer's preferences, and the budget line showing the constraints on what the consumer is able to acquire. And then from that we can determine the quantity or the combination of goods that our consumer is willing and able to purchase at given prices in such a way that they are attempting to achieve that which they most prefer given the constraints they face. So let's get going with that. Here are our consumers' indifference curves. This is a few selected indifference curves, and we know that our consumer will want to move to the highest indifference curve they can. They most prefer more. They prefer more rather than less, so they'll always want to move to a higher indifference curve if they can. Now we need to put in, obviously they can't just have whatever they want. They're going to be constrained by the budget that they have and the fact that they have to pay prices for the goods that they're interested in acquiring. And let's say we've got a budget line which is due to the consumers, our consumer, say Tina, having a limited amount of income, and the soft drink and the movies have certain prices. So what we know is this: our consumer will want to get to the highest indifference curve they can, but they will be constrained by the budget line. So they will move, they would like to be on indifference curve I2, but they can't get there. The budget line constrains them. So they'll go to the next best indifference curve they can get to, which is an indifference curve which is just touching the budget line, just on the budget line, in this example, at just one point, point C. They can't get to a higher indifference curve than this. A higher indifference curve than that would be beyond their budget line, beyond their budget constraint. So point C will be their best affordable point. That will be their optimal point. It's at this point that they are they're obtaining that which they most prefer given the constraints that they face. Point L, for example, is on a lower indifference curve, and therefore is less preferred to any point on indifference curve I1. We can see at points F and H that our consumer would be utilizing their entire budget. That is, they would be spending all of their money, given the prices of movie tickets and soft drinks. So they'd be on the budget line, but they're not on the highest indifference curve they could possibly get to. It's only at point C that they're utilizing all of their monetary resources. They're spending their whole budget on the highest to get a combination of goods which is more preferred than all of the others that are affordable to our consumer. So they'll choose C. So far, so good. Just one more technical note, that at point C, the indifference curve will have a certain slope. and we call that slope the marginal rate of substitution. That is a change in y, or a change in the number of drinks, due to a tiny change in the number of movies. As represented here, this is the marginal rate of substitution, dy dx. The d here simply means a very, very tiny change. So we've got the tiny change in drinks relative to the change in movies. So this is telling us about the slope of the indifference curve at any point, and in particular we're interested in point C. What is the slope at that point? Well, it will be identical to the slope of the budget line, because the budget line will be tangential to the indifference curve I1 at point C. So if we find the slope of the budget line, and we've discovered previously that the slope of the budget line is the price of the horizontal good over the price of the vertical good, the good on the vertical axis. So px over py, the price of movies over the price of drinks. Now, the price of movies was $8 and the price of drinks was $4, so we know the slope of this budget line is 2. And since they share, the budget line and this highest indifference curve share this common point, they must have the same slope at that point, at that tangent point. So we know that the marginal rate of substitution at point C must be the same as the slope of the budget line at point C. So the marginal rate of substitution here must also be 2. This is a condition for when we have two imperfectly substitutable products, such as soft drinks and movies or whatever. And so we've got budget lines that are straight and downward sloping, and we've got indifference curves which are convex to the origin. It's a condition of optimality, a condition of the optimal choice of our consumer, that the slope of the budget line will equal the marginal rate of substitution. Okay, that's a technical point, but now let's move on to the really interesting stuff. What we're going to do now is use our budget line and indifference curve analysis to construct a downward sloping demand curve, which you'll remember from way back when is actually the point of the whole exercise, to explain why it is that the demand curve would be downward sloping. That is, when the price falls, the quantity demanded rises, and vice versa. So here we've got our indifference curves, a couple of indifference curves. So we've got an indifference map, or samples of an indifference map. And let's say we've got the budget line drawn here. So we're saying that the price of movies is $8 a movie. And we found that the point of tangency of the budget line and the indifference curve, point C, gives us the quantity of soft drinks and movies that our consumer will be willing and able to purchase. The maximum quantities of movies and soft drinks that they'll be willing and able to purchase. So, if we take the data from here and draw a graph where on the vertical axis we'll put the price of movies, and on the horizontal axis we'll put the quantity demanded of movies. And what we know is the price of movies, which helps us to construct our budget line, the price of movies is $8. So we can put $8 on the vertical axis. And we know that in this situation we've drawn here, the maximum quantity of movies that our consumer will be willing and able to purchase at $8 is 2 movies per month. So far, so good. So we've got 1 point so far for a demand curve. What we need is another point in order to construct a demand curve. And what we want to do is change the price of movies and see what happens to the quantity demanded of movies. So, if we change the price of movies to $4, the budget line swivels outwards. That is, our consumer is, due to the cheaper movies, is able to purchase more movies than before. And so the budget line swivels outwards, and the consumer will now be able to shift to a higher indifference curve. So a more preferred combination of soft drinks and movies. It's further away from the origin point, this indifference curve. And we can see there at point J, the point of tangency between the new budget line and the new higher indifference curve gives us a maximum quantity demanded of movies of 6. We don't worry about the soft drinks for now, just we're interested in the movies. So, at the price of $4, which we can represent on the vertical axis down here at $4, the consumer, our rational consumer who is attempting to achieve that which they most prefer given the constraints they face, will now select 6 movies. So at the price of $4, they select 6 movies now. They will demand 6 movies. Okay, we've got enough points here, point C and point B, in order to construct a demand curve. Join the dots, and voila, we've got a demand curve for movies. Absolutely thrilling. So this is the theoretical analysis that enables us to derive a downward sloping demand curve, showing the law of demand. When the price of movies falls, the quantity demanded rises. A thrilling theoretical breakthrough, if I do say so myself. But wait, there's more. In the 1930s, a famous economist by the name of J.R. Hicks, or John Hicks, tried to disentangle 2 parts or 2 aspects of the law of demand. It was argued that there are 2 reasons why the demand curve might be downward sloping. One is that when the price of a good falls, the relative prices between 2 goods changes. So when the price of a good falls, it becomes cheaper. And when it becomes cheaper, consumers will switch to the cheaper substitute. And this causes the quantity demanded to rise. But that's not the only thing that happens. When the price of a good falls, it means that consumers' real income, that is the purchasing power of their money, goes up. They can afford to buy more. And so, when prices fall, consumers can afford to buy more of a product. If it is a normal product, they will increase the quantity demanded. So you have these 2 effects occurring. One we call a substitution effect, and the other we call an income effect. And John Hicks tried to demonstrate these 2 effects using indifference curves and budget lines, and succeeded in doing so. So here we have our consumer maximizing their satisfaction given the constraints they face. And as we've seen already, when the price of the movies fell, the consumer was able to shift to a higher, the budget line swivels outwards, and the consumer was able to move to a higher indifference curve. Okay, so far so good, but we can't discern the two effects here yet. We want to see the increase in the quantity demanded from 2 to 6. We want to see how much of that was due to movies simply being relatively cheaper than they were before, versus how much did demand go up because consumers simply could afford to buy more than they could before, because they're an increase in their real income. So here was Hicks's way of decomposing these effects, pulling these effects apart so we can see them. So what we want to do is, we want to see the change in the relative prices. That is, we want to see movies being relatively cheaper than they were before, but without shifting the budget line upwards. So what we want to do is, we want to take the slope of this new budget line, just the slope, and impose it back on the original indifference curve. So imagine the consumer is just as happy as before, but they've chosen a different combination because movies are relatively cheaper. So we're shifting the new budget line back to the point where it's just tangential to the original indifference curve. And this gives us a new point of point K. So this is kind of, in a sense, it's hypothetical. We're saying that if movies were relatively cheaper than before, but the consumer couldn't afford to buy more of both products, then they would simply switch between soft drinks and movies. So we get a substitution effect. So we get an increase in the quantity demanded of movies, which is simply due to changing the slope of the budget line. That is simply due to a change in relative prices. So here we've isolated the substitution effect, which means the remainder of the increase in the quantity demanded must be due to the income effect. It must be due to shifting the budget line outwards. That is, moving from the theoretical K point to J. This must have been due to being able to afford to purchase more, rather than simply movies becoming relatively cheaper. So movies become relatively cheaper and we shift to point K, and then, so there's an increase in the quantity demanded, and then there's an increase in the quantity demanded due to being able to afford more, the income effect. So this is the Hicksian decomposition. One thing that we should note here is that this assumes that movies are a normal good. A normal good means, or the definition of a normal good, is one where consumers want to buy more of it if their incomes rise, if they can afford to buy more of it. Right? But a little puzzle for you to think about is, what if movies were an inferior good? An inferior good is when your incomes rise or you're able to afford more, you decrease the quantity demanded. What would happen in that case? How would we represent that using our indifference curve and budget line analysis? That's something for you to just puzzle over.